I built a database tool called Axel, and what it does is it basically takes your schema and your query, then it generates it as SQL outputs. It's a domain-specific language for this particular case, right? For me, SQL is too verbose to be written and built upon to have like end-to-end typing. So the problem is there, and Axel is what I built to be my solution for that. Right? So the way Axel works is it has two major components, which is the schema language and the query language. The schema language is used to define your schema, how your tables should look like, inheritance, database index, constraints, data types, aliases, enums, and etc. Even down to using database triggers, right, which is a very, very cool Postgres feature that is highly underused. Same thing is one feature most people might be able to relate to is a rewrite. So basically, what a rewrite does is you can specify a rule that says whenever an update happens on this field or in this table, rewrite the database field to a specific value. Like in this case, I said whenever there is an update to the table, rewrite the field to have the current dates. So that would easily help me implement the updated art concept, right? Which is nice. Out of the box, you get it from some database as well, but most of the time you don't understand what is going on in background. So in background, this is using Postgres triggers. So you have constraints as well. In this case, you have field level constraints, and as we've seen here, this is type level constraints. No, this is type level constraints we have here. But in the other case, we have field level constraint as well. Then you can also have computed fields in your database, which again it is going to be typed whenever you generate your database your AQL. Whenever you generate the query language, it's going to add typings for everything you've done so far. Do you get? Then for functions, this is not up to date. Like this functions documentation is not up to date, but the idea is the same, right? You can add database functions to perform certain actions for you, but in this case, it is specifying using functions with triggers alone, right? More on functions soon. You can follow up with the documentation like to know more stuff like that. Then the triggers, you have something in Postgres called triggers. If you don't know about triggers, you should really check it out. You're missing a lot. Like very, very cool feature. All right. So basically, a trigger is a way to let your table know, like, or let you perform an action when some events occur on your table. For instance, if there is an update, if there's an insert or delete on your table, right? You want specific actions to occur. Like in this case now, I want whenever any update or insert or delete is happening on the application type, I want to create an audit log in this case, right? So, I mean, you can do it easily like this, easily. You have a guarantee that this would always log like from your database. You don't have to incur extra code when SQL can just do it for you, really. Then in this case as well, you can pass a function, right? That was what we saw the definition in this other section here, right? You can pass a function like this to your trigger instead of adding it in line, just like we've seen here, right? Then if you look through the parameter section, you have named parameter, you have optional. That this is now AQL, right? The query language for Axel. It contains a lot of cool things, which one of them is the parameters. The parameters is very nice because you can add typings to it, even if you want to do some custom behaviors. For instance, let me give you an instance of yeah, before we get to that, you can also have optional typings, like something like optional parameters rather. So when the SQL is generated, it would look something like this, which is something you'd have written manually if you were working with raw SQL, right? Then you would have the typed parameter as well, which you can see from here. I explicitly typed the limits to be int 32 and I made it optional, right? Then okay, this description is also not up to date because you're supposed to be able to add typings for even JSON. You can type a string a valid JSON string, you can type it to a proper JSON field in your code, right? You can do something like that as well. Same thing with select, you can do the normal select, you can do a multi-select. This is one cool feature you might like, right? So in maybe Postgres, in Prisma rather, you would want to do maybe find first or something like that. So this is similar to find first. By default, you will just do select user and it would return a single row for you, right? And when you add multi to the front of the select, it means you want multiple user fields to be selected. That's just what it means, right? So yeah, the next thing you have is filtering, which comes as it is, right? From here, this is a very good look-alike to Postgres filtering pattern, as you can see, right? So from here, you get this kind of query generated, which is nice. Then you have ordering and pagination. I mean, the usual Postgres stuff. So everything you see in Axel is like as close as Postgres can be to any user, right? So that's the idea behind it. Then you have computed fields. You can also have computed fields in your AQL as well, not just your ASL. So from here now, you see I'm adding a computed field for post and primary organization in this case, right? So this is going to return a single object, and this is going to return, the post here is going to return multiple objects, right? So you can examine what query is generated in this case, right? So in the future, I'm looking at the way where you can specify how you want your query to be generated. Some people are opinionated on should you be writing this kind of query or not. Some people, whereas some people agree this is a minimally okay query for them, right? Then another thing you can do with Axel is you can have subqueries during your updates and inserts. For more on subquery, you could check this section out, like no more on subqueries. Then you can have nested shapes as well, which is a cool thing I personally use like a lot. So I have a relationship here for the author field, but I want to select the ID and the email of the author, right? I can use a subquery here, but if it's a relationship, I can just access it like this directly. And at the end of the day, I get this kind of SQL, right? Which is cool. Then the next thing we have is here. Okay, we've gone over multi-links in the first place. Yeah, we've gone over multi-links. So you can have aggregates too. Aggregates is really underdeveloped in this version for now, really. So there's still going to be more on aggregates later on. Then you have your typical inserts. Then another field most people probably don't know exists in Postgres is the conflict feature. So basically, the way it works is whenever you want to do an insert, let's say your email is unique, right? You can handle the conflict. So this is basically error handling for Postgres natively. So if a conflict happens, you can either do nothing or you can update the field in like we've seen in this case here like this. So you can say if a conflict happens on the email field, right, do an update. This is the meaning of what we have here. Unless conflict on email, else update. That's just what it is. It's a really clean feature for Postgres, but most people don't get to use it more because of the tooling's availability and all that. Like most tools don't really implement it that much. So then we have expressions, which is the operators are generic, the literals are also generic. The path expression is the cool part in this case. So you can say this is a relationship, right? An installation has installation ID. You can keep nesting it that way. It's not too recommended you do something like this too much, but it is always something you can do as well, right? It's possible with Axel. Then you can cast types as well. Exactly. So yeah, this is a good use case of type casting, right? So from what you can see here, you have your secrets field, which you don't want it to be shown outside, right? So you just type it as a JSON string and you cast it to JSON just like this. Similarly to what you can do in fields like this as well, you can cast the type. But in other cases, it is inferred. You don't have to cast it, right? If a type like this is added without typecasting, you get a warning and a type of any would be generated for you. The equivalent of any in your programming language anyways would be generated for you. Then we have directives, which you can read it and understand what directives are. They're really straightforward, no big deal. It's just for your query generations. That's where it is important. Then the last thing you have is just grammar reference. You probably don't need to check that. Then the CLI commands, they are not a lot at all. So let me check. Let me show you. So the schema commands are about three, I believe. Okay, four. There is the status command to check the status of your migration. There is down, which basically takes an optional parameter of if you want to do a rollback, like go down 3 levels or 1 level or 5 level, you can do that as well. Same thing with up. Up does not take any arguments per se. It just, it migrates it to the latest. That's what it does. Then generates takes in an optional name. You don't have to pass a name to it. So it basically generates an SQL for your incoming schema. It does a diff on its own, so it knows what query that exists already and the new one. So it does that on its own. Then yeah, that's basically what we have. And the query command, you can run validations, you can compile your query to SQL directly from here, or SQL files or SQL screens or whatever. You can compile for like an entire folder as well if you don't want to compile your files one by one, right? Yeah, this is batch compilation of your like queries, right? Then you can have a code generation workflow, which is what I mostly go for. For now, you have Golang and TypeScript that comes bundled with Axel. So once you do this, you can generate your Axel query in Golang, and in this case, you generate it in TypeScript. For now, this has not been implemented, but you get the idea. Then yeah, I think that's really all for everything we have in Excel. The idea is simple. It's something that is meant to just generate SQL for you. Really, that's just what you have to see it as, right? Yeah, I think I'll be giving more updates on Excel as I progress. Right. If you have questions, if you have anything, just let me know. I'll be sure to answer them to the best of my ability. Yeah. Thanks. I'll see you guys later. Cheers.